Hello everyone, I'm Jean. This video briefly explains my understanding of the XAI605 final exam repository. The objective is to train a robot manipulator from human demonstrations to perform a sequential task. Open a drawer, place an object inside, and close the drawer. The environment is implemented in this film. Actions are represented as delta and effector pose, meaning the policy predicts relative position and orientation changes plus a gripper command. The environment provides both robot proprioception and environment state, including object poses and drawer joint positions, enabling context-based manipulation. The dataset consists of pre-recorded human teleoperation demonstrations. This film shows how demonstrations were collected, and in this film, replaced the recorded trajectories and confirms that the three task stages are present. These demonstrations are used directly for imitation learning. While Transform IPYNB defines how raw demonstrations are converted into training data, it specifies the action representation, the observation structure, and the temporal action horizon. 4 key variables are defined in the film to determine how data is processed and fit into the model. Since I cannot evaluate the model's final output, the default parameters from the experiment are used here, but I think it's gonna be more effective than other options because this facilitates the model's learning of smooth, continuous actions. While each observation contains robot state and environment state composed of object poses and drawer joint positions. Object poses are sorted for consistency, and the drawer joint values are explicitly included, so the policy can observe opening and closing behavior. For the model design, I referenced the parameter configuration to implement a 7-layer, multi-layer perceptual and employing the ReLU activation function and Chi-mean initialization. It is capable of processing different action types, enabling flexible adaptation to the task requirements. However, as mentioned earlier, the primary focus here is on handling the relative change in end effector pose. The rest of the training and evaluation pipeline remains unchanged. The training results are as follows. Well, we can see, but the decreases in loss indicates that the model has learned to replicate the action in the training data, but it may not have learned to generalize and complete the task. Then, as required, I passed the JIT verification. Well, in summary, this repository provides a clear separation between data pre-processing, environment interaction, and policy learning. My modifications focus on the required GOTD sections while keeping the overall framework intact. Thank you for watching.